Hello, and welcome to the Solving Rational Functions Day 1 video. For this video, as well as the next one, we're working off the same worksheet with just a bunch of problems where we solve for rational functions. So in this video, we're going to be going over problems 17 and 19 from that blank sheet or blank notes, so please make sure to take a look. I just kind of want to show you some various algebra steps you may have forgotten about and about checking your work. So let's get to it. Problem 17 is x plus 2 over x squared minus 4 is equal to 3 over x minus 6. So first thing you're going to want to do is, if you have the ability to factor, factor. I notice right here, this x squared minus 4, this is a difference of squares, and this can be separated into x over 2 divided by x plus 2 times x minus 2 is equal to 3 over x minus 6. From here, I go, hey, we have a factor of x plus 2 in our numerator and in our denominator, so we can cancel both of those out. Now, when we cancel those out, that doesn't just leave us with this x minus 2. That x minus 2 has to stay in the numerator. So this is going to be, where are we? 1 over x minus 2. Pardon me, it has to stay in the denominator, not the numerator. And that's going to be equal to 3 over x minus 6. Now, when you have two fractions like this, or proportions, if you have only one fraction on either side of the equal sign, this is the one and only time where you can use cross multiplication. This is going to get us 3 times x minus 2 is equal to 1 times x minus 6. From here, I'm going to factor in or distribute the numbers out in front. So we get 3x minus 2 is equal to x minus 6. From here, I'm going to subtract x on both sides and get 2x minus 2 is equal to negative 6. Oh, pardon me, I just realized, I'm going to go back and erase, when I multiplied in the 3 times negative 2 is negative 6, so it should be negative 6 here and here. So we should actually have 2x minus 6 is equal to a negative 6. And then from here, when I add 6 to both sides, I'm going to get 2x is equal to 0. And then to get x by itself, I'm going to divide both sides by 2. Now, 0 over 2, that's okay. We can have 0 in the numerator, but not in the denominator. And that's just going to leave us with 0. So we have 0 as our final answer. Now, to make sure this actually works, I'm going to take this number, plug it back into my equation, just to make sure that these two pieces are equal to each other. So I'm going to do my check over here. We'll have 0, so this is our check. 0 plus 2 over 0 squared minus 4 is equal to 3 over 0 minus 6. On my left side, 0 plus 2 is 2. 0 squared is just 0, so this is over negative 4, is equal to 3 over negative 6. If I reduce my left side, I get negative 1/2. And if I reduce my right side, I also get negative 1/2. Yay! So we know we've done this correctly, and we can write our final answer. We're going to write this in a solution set, so with curly brackets, of 0. Now, we're putting it in a solution set because we're saying this is all of our final answers. Not all of our answers are going to work. We'll spend more time on that in our next video, but for right now, I just want to make sure that you're practicing checking your work. Now let's move on to problem number 19. I'm going to scroll here a bit. Okay, let's see. Problem number 19 is 8 over a squared plus 1 is equal to 9 over a. I'm sorry, I know that my 9's and my a's look fairly similar. Now, when I take a look at this, there's definitely a few different ways to do this problem. But I take a look here and I go, you know what? I want to add these together. But in order to add these together, I need to have a common denominator. So I'm going to take this 1, and this 1 is really secretly over 1, since any number can be put over 1 to become a fraction. I'm going to multiply top and bottom over here by a squared to make sure that I'm going to have common denominators. So I end up with 8 over a squared plus a squared over a squared is equal to 9 over a. Now that I have common denominators, I can add my left side together with 8 plus a squared over a squared is equal to 9 over a. So from here, to get rid of the fraction, I go, hey, if we're dividing by a squared, I'm going to multiply by a squared. But if I do that to one side, I have to do that to the other. So on my left side, if I'm multiplying by a squared and dividing by a squared, I can cancel those out. I'm just left with 8 plus a squared. And on my right side, this one's a little trickier because I'm multiplying by a squared, but I'm dividing by a. So if I have an a squared up here, remember this a squared, this is the same as a times a. So if I'm multiplying by a times a and I'm dividing by an a, I can cancel out this a in the denominator and one of those a's, but I still have one left over. So my answer for my right side is going to be 9a. From here, I go, you know what? I have something with a squared, something with just a variable, and something with a constant. I'm probably going to have to factor. So I'm going to move everything over to my right side, from my left side. But first, I'm going to just switch my a squared plus 8, because I'm kind of used to that. I'm going to subtract 9a on both sides. Get a squared minus 9a plus 8 is equal to 0. From here, I'm looking for two numbers that multiply to 8 and add to negative 9. It's going to be a minus 8 times a minus 1. Now remember, if I'm trying to get a by itself, I'm going to set each of these factors equal to 0 and solve. So I eventually end up with a is equal to 8 and a is equal to 1. So now that I have some final answers, I need to go through and check my work. So for my check, first I'm going to check with 8. So that's going to be 8 over 8 squared plus 1 is equal to 9 over 8. So let's see, this will be 8 over 64. Or actually, you know what? Let's, instead of doing it that way, let's cancel out with that 8 and then the squared. So we're just left with 1 over 8 plus 1 can be written as 8 over 8 is equal to 9/8. When I add my left side together, I get 9 over 8 is equal to 9 over 8. So we know 8 works. And then if we try this with 1, we get 1 over 1 squared plus 1 is equal to 9 over 1. Oh, excuse me. This is probably 8 over 1. Let's see, we end up with 8 plus 1 is equal to 9, or 9 is equal to 9. So we know that answer also works. So after you've worked through your problem, please make sure to plug them back in just to double check that they work. These both do. So I'm going to put my answers in a solution set in those curly brackets from least to greatest. So this is an example of just 2 of the problems that you'll see on this Go Formative. This Go Formative has a few different types of problems which we'll be practicing in class together as well as on your own. So please make sure to ask me if you have any questions. I look forward to seeing you next class period.